Hello, everybody. Welcome to TGI Kubernetes. My name is Joe Beta, and I really appreciate you joining me for yet another TGI Kubernetes. This is episode 135, which is absolutely crazy. And for those who don't know, TGI Kubernetes is a weekly live stream that we do. This is a lot of folks in VMware doing Tanzu stuff, where we just really talk about, Kubernetes and things in the Kubernetes ecosystem. Oftentimes, it's things that we're not experts in, so we really, explore things together and learn together. I'm Joe Beta. I'm one of the co-founders of Kubernetes, and was CTO of Heptio, a startup that got bought by VMware, and now I'm a principal engineer helping to coordinate a lot of the Kubernetes stuff that we're doing across VMware. So I like to start off by saying hello to everybody from around the world. Also, always acknowledging that this is the worst time to do a live stream, but here we are regardless. Oh, somebody's to. Oh, hey, my son just walked in. How's it going, Theo? I'm doing TGIK. He just wants to pet the dog. He doesn't care about me. And so, yes, I want to say hi to everybody. Starting out with Rory from Scotland, Lamati, good to see you. Piyush from India, early morning, I know, right? I talked with MSV, who I think is a journalist influencer in India last night at 10 p.m. my time, which I think was almost a reasonable time for him. Chaim from Israel, good to see you. Yeah, so Antonia, I've been talking to Antonia for quite a while. On Twitter, I'm like, this particular topic, we're going to be going into Antrea, which is a CNI system. I'm actually a little bit nervous because I'm not a networking expert. I know enough to be dangerous, but I think this is part of the fun, is seeing me flail and not know what I'm talking about. Dieter from Germany, good to see you. Vivek, Raiko from Germany. Hake, good to see you. Savvy, awesome. So many folks. Okay, so I want to call out to everybody, but I love seeing you say hi in the chat. That really makes me happy. So thanks for joining. So the way that this works is that I usually spend the first 10 or 15 minutes and we go over what's been happening in the Kubernetes world over the last week. Click on some links, read some articles together, stuff like that. And then we jump into the topic that we're driving for the day. And so the topic today, like I mentioned, is Antrea, which is a networking system, relatively new in the Kubernetes world, but maturing very, very fast. I think we have a lot of folks from the team, hopefully, who've joined us here, so they can tell me when I'm going off the rails and screwing things up. But yes, and I'm wearing the Antrea shirt. They made sure that I was able to get one in time to be able to do the broadcast, which is really cool. All right, we got Cody here, who's part of the team. So good to see him, and we have Jay also. And so when I start doing bad things, they're going to correct me in the chat. So thanks and Janjun, good to see you also. Thanks for joining to let me know where I'm going wrong on things. So let's jump right in and start going through. The notes that I'm going through, that I'm working through here, these things are, it's a shared note, so feel free to join in and add some notes, put some time codes in there if that makes sense for you. And this is a great way to sort of crowdsource notes for this and actually share things that we see come up. This is using this really cool service called HackMD, which is sort of a shared editor for Markdown. And you can get to it. I think George put a link to it. Thank you, George, in the chat here. It's tgik.io/notes. So feel free to join in. And then I'll check this into the TGIK repo after the fact and put a link to it from the YouTube description. All right, so let's go through what's going on here. So George does a lot of the curation of these notes. And so first of all, thank you, George. I really appreciate it. And there's not a lot going on in core Kubernetes this week. But I think one of the things that is really interesting, and I love that we now have some of this clarity here, is that we have a whole bunch of we have these idea of KEPs, right? The Kubernetes enhancement proposals, which is a structured way for people to plan how we're going to move and evolve and improve things. Oh, I got to switch to my to the screen here. Yeah, so here's that that HackMD, and then you can see that you know, George listed out a bunch of the KEPs here. And so we're gonna dive into some of these because I think there's some really interesting stuff going on. So, you know, let me just let's see. We'll go through and close some links here. Let me just click on these things and we'll move through them. I took a quick look beforehand. So the first one here is adding a kube control debug command, which really makes it a lot easier to use some of the new capabilities that are coming with things like ephemeral containers. And also, you know, reading through it looks like it makes it easy to have sort of multiple different ways of debugging different containers in different situations, whether it's in ephemeral containers, restarting with a modified pod spec, or start and attach to a privileged container using the host namespace. So it looks like some really good ideas, like taking these debug workflows that can be really fiddly and making these things be a lot more approachable. Looks pretty cool. So the next one, and this one is interesting. It took me a while to understand. I'm like, we don't already do this. This is graceful node shutdown. So this is what happens when a node is shutting down. Can we actually be responsible and shut down the pods appropriately? Now, this does happen, I believe, if you cordon and start draining the node. It'll actually, at least, you know, for most of the pods on that, it'll allow them to do a graceful shutdown. But if the node is shutting down via other means, like let's say you're in a cloud provider and you go up and you start terminating the node from the outside, or which is kind of the equivalent of holding, you know, pressing the power button on the virtual machine, then you don't see graceful node shutdown. So I believe this is a way for the kubelet to actually understand what's happening in the host kernel, react to the shutdown events, and make sure that it can shut down the pods in a responsible way. So that's the type of just sanding off those rough edges and continuing to make this stuff better over time that we really love seeing. This one's really interesting too. This is container resource based pod autoscaling. So right now, when you do horizontal autoscaling, which means you set the requests and limits for a pod, it doesn't actually work down to the container level. It works across the entire pod. So now the goal here is to make horizontal pod autoscaling scale based on individual container resource usage. So make it sort of container aware versus just looking at the pod as a whole. So that's really, really cool. So this is stuff that's coming on different timelines, but it gives you a sneak peek of the type of things that people are working from. This is a little bit of a PSA. There's this thing in Kubernetes resources, which is a self-link, which is really meant to be sort of an identifier, so that if you see the object outside of where you got it, you end up seeing that path there. I think the idea was that at some point we may get into a situation with Kubernetes where you're referencing the same object from different directions and you want to have a canonical name or location for that thing. It turns out it hasn't really been used and it's confusing. And so Wojtek has been working for a while to make this, to remove this and deprecate it in a reasonable way. And then finally, this one makes me very, very happy. Early on in Kubernetes, as we picked terminology, we originally called the control plane the master, and then the individual nodes, we named those things minions early on. And this was influenced by, we were using SaltStack under the covers, which was just purchased by VMware, funny enough. We were using SaltStack under the covers to be able to sort of, get Kubernetes installed and running, and it was a total mess and disaster early on. But that's where we got the minion nomenclature. But over time, minions caused confusion because that's what Salt called their things. So now we had the master and the nodes. But master still is not a great term. It's not super descriptive, and it doesn't actually really encapsulate the fact that there's not a single master. It's really a group of components that actually comes together to create the control plane. That terminology master actually didn't show up in that many places in the actual Kubernetes code. A lot of it was documentation and how folks talked about things. Oh, and I'm going to give this a heart right now. And but there's a few places where it showed up, and this was as we were coming up with the sort of canonical recommended ways to install and manage Kubernetes using kubeadmin. We wanted to create a label or a taint on the control plane nodes such that you could actually coordinate out your workload nodes versus your control plane nodes and make sure that you didn't have workload pods running on the control plane and perhaps causing some security or availability issues. But we called that master. And so this is actually fixing that and renaming that label and taint to control plane, which sounds easy. You're just changing a string, but we have to do it again in a responsible way such that folks who may have written code or manifest that work against the old nomenclature can continue to work. All right, so those are the KEPs that are coming down the pike. So good to see those. Super cool. All right, so other things that are happening further afield. So first of all, earlier this week, our friends at Pulumi had this cloud engineering summit, and I was invited to sit on a panel with a bunch of other folks to discuss sort of the state of cloud native in Kubernetes and configuration. And it was a really good panel discussion, and I think I encourage you to go ahead and watch it on replay. But beyond that, there's just a lot of great speakers here, a lot of familiar, friendly faces, and so it's really good to see everybody come together, even if it is a virtual conference. Hey, look, there's Duffy. To come together and really make this share their knowledge and share their experiences there. So you can see, I believe they're doing replays now. Yeah, so you can go through. Here's the panel that I was on, and you can now watch on demand. There we go. So I encourage you all to check that out. It looks really cool. So Duffy is presenting at KubeCon an AMA keynote with Ian, Brad, and Rory, which looks really cool. And I love the sort of the AMA and sort of making this stuff more accessible with folks like Duffy and the rest here. They're looking for questions. And so if you have questions that you want to ask this crew, please go to this topic in the Kubernetes message board, discuss board, and leave your questions there for them. They really want to get some good questions for their KubeCon keynote. Let's see, other stuff. Rook graduates from the CNCF. Congratulations to Rook. I don't think we've ever done a TGIK on Rook. That might be fun at some point. That'd be really cool. Add that one to the list. This is cool. I haven't had a chance to play with it, but it looks really cool. Somebody went through and hacked up Doom and created monsters to represent pods and stuff so that you can actually run this thing as a Kubernetes client. And if you kill the monster, it actually kills the pod. And then I assume if the replica set actually spawns a new one, a new monster shows up. I'm not quite sure how that works, but that looks like a lot of fun. We should totally try that at some point. Oh, you can kill namespaces also. Run kube Doom inside Kubernetes. Oh, so what, I guess like if you can actually commit, you can kill the game server as you're actually running against it. That sounds like a lot of fun. I think we mentioned this before. There's some changes coming to Helm, the deprecation of V2, and also changes in terms of the repos and stuff. And so if you rely on the Helm community, I definitely encourage you to understand what's going on here. And make sure that you prepare. They announced these changes over a year ago, so this is an ongoing thing. But as these sort of like, I'll deal with that in the future, as these things start getting a lot closer, I think we need a lot of reminders that, yeah, no, really, you got to deal with it now. This stuff is really going to happen. And so heads up on that. And then finally, and I saw that Steve was here, Steve Sloka, who wrote this, Contour 1.9 is out, and this is chock full of awesome features. And so I really love the engagement and the progress that we're seeing with Contour now that it's part of the CNCF, and really, really excited about that. We're starting to see a lot more contributions, and we're starting to see it used in a bunch of new places. As we're investing and have a bunch of coworkers that are working on Knative, I think Contour is really emerging as a really easy go-to ingress controller that's compatible with Knative also. But some of the cool features is external authorization support. So that way you can use Contour as a authenticating proxy. And the idea is that the proxy doing the authentication or the code doing the authentication is not in the data path. It's only there when you're doing the auth, and then everything flows through Envoy normally. I believe that's how it works. And so I believe in that case, Envoy will drive the auth, but it doesn't actually interrupt the data path. And some of the solutions that I've talked about in the past for doing that, I believe that there's a TGIK on securing the dashboard, and I did a blog post on that also. When you look at that, the authentication component ends up being in the data path, which can really increase the load and latency and reliability there. So that's super, super cool. There's a demo that you can watch there on that. There's cross-origin resource sharing support, core support, which is great. There's backend TLS client authentication. So that means that when the Envoy that's backing Contour initiates a connection to your downstream server, your upstream server, your backend, I like saying backend, it actually can use a client certificate as it's doing that. So that way you can have that bi-directional trust with the load balancer in the middle. And then finally, they're moving to V1 custom resource definitions, which come with a bunch of advantages. But what that does is it moves the minimal version for Contour up to 1.16. So just something to be aware of there. So that is the news of the day, unless folks have other things that they'd love to go through. A lot of cool stuff going on there. All right, so let's jump into Antrea. So I was thinking about this. Oftentimes I've been debugging and demoing stuff using Kind. And then when it comes to, a lot of the stuff that we do and explore here, the fact that you're running a cluster locally and it's not, it's not a production cluster, there's a few things that kind of get complicated and in the way, like, the way it deals with volumes and stuff like that. But when you start talking about networking, I think you really want to start seeing it in a more production-like setting here. And so the first thing that I want to do here as we get started is build a cluster from scratch on AWS, and then we're going to install Antrea into that cluster as the networking support from the get-go. And so this will be a little bit, yeah, that's a good question, Lamad. He's asking, where did the name Antrea actually come from? And if the Antrea folks could actually help, could help inform us there. I'm actually not sure. And I searched for it because I'm like, what is an Antrea, right? Maybe it's like a boat or something, who knows, right? And I couldn't really find anything. But the tool is called Ant Control or Ant Cuddle. And so that's why the image, the header image that we have here that I picked this week is an ant. But I'm not sure where the name came from. And then Antonia. Okay, Antonia's asking sort of what is the question between something like Antrea and Istio? What is the one versus the other? That's actually a really good question. So let me go through and give a little bit of context there. In Kubernetes, sort of networking happens at different levels, and roughly this lines up with the OSI networking levels, and we'll talk about these things. So OSI networking model. You can look at this. We'll look at the Wikipedia article on this. It's the 7-layer burrito of networking, and there's usually a diagram here. And so Antrea, it really works down at these lower layers. And so the common CNI, which is the type of system that Antrea is, which calls what does CNI stand for? Common Networking Interface. Ends up being a way to actually plug in virtual software defined systems for doing sort of raw networking at these lower layers. Container networking interface. That's right, container networking interface. Whereas as you start getting towards things like Istio, it actually deals much higher up at the application level. It understands things like HTTP, how to actually do routing and rate limiting at that level also. Now, it's not totally clean because there is a certain level of overlap. Things like Istio will also end up doing encryption and authentication using mutual TLS, essentially the same protocol used to secure connections to your bank. And that starts to look more like down at the sort of layer 5 stuff here is where TLS is. So, but in general, sort of like, layer 5, 6, 7 is the area that Istio plays in. And, layers 3 and 4 is the place where things like Antrea actually play in. So that ends up being the split there. And, there are systems that try and sort of do all of this all in one, but oftentimes you need to be able to mix and match different environments across these things. And so splitting them up makes a ton of sense. Yeah, Cody's saying, yeah, actually all the way from like layer 2, I think layer 2 to 4 would be CNI. And then like with some of the TLS stuff, we end up with layers 5, 6, and 7. Is CNI also supposed to do encryption a la WireGuard? That's a really good question. There are many ways that you can do encryption. I think Antrea, and as we get into some of the specifics, does support, and we're not going to probably test it out today, encryption at the link layer, at the network layer, at layer 3, using this protocol called IPsec. And that's sort of, it's a pretty raw, invisible encryption. You can do that at higher layers. You can do it in a hidden way with something like Istio, which ends up being at the sort of the session layer at layer 5. And when Istio does it, it's still pretty much hidden from the application, but you view sort of Istio and the application kind of as an application. This is why the OSI model you always have to use a little bit of creativity when you're applying it to newfangled architectures. But you can also do encryption at even higher levels. So there are, encryption that happens very much as part of the application there. And so I think if you look at something like, and I haven't dug in, I'm not an expert here, but my understanding is that you look at the encryption protocols used by something like WhatsApp or Signal, those things are going to be very much embedded in part of the application versus being something that's sort of hidden at the sort of networking layer. And so I don't think there's one right place to do encryption in this stack. There's definitely pros and cons across doing it at different layers. All right, so all right, so let's keep going. So we're going to set up a cluster there, and then we're going to install Antrea. So that's the game plan, and then we're going to start playing with some of the unique features of Antrea. That's the game plan. But first, I want to talk about sort of why Antrea is a thing, which I think I see some of the questions here in the chat about this. From a VMware perspective, we made the decision to really start, investing in Antrea, and there's a bunch of reasons for why we decided to do that. And we think that these make sense for a lot of other folks, and so that's why it's an open source project with an idea of growing that community more and more over time. The first thing is that Antrea under the covers uses Open vSwitch as its data plane. And so the thing that's handling packets here is OVS. Now, there are other mechanisms for doing this. So I think, the common ones are you can do a heck of a lot with IP tables, and that was what a lot of the early networking for Kubernetes ended up looking like. There's also a lot of folks that are doing a lot of work with eBPF, and eBPF is essentially a way to write and compile programs that run in kernel. So it's a very sort of dynamic driver model almost that lets you plug into a whole bunch of different things. A lot of great work can be done with eBPF, and eBPF, what does it stand for? Extended Berkeley Packet Filters, I think. So eBPF is, started with a view of like, how do we rethink how we want to deal with, networking policy, but now it's kind of expanded and does all sorts of really fascinating things inside the kernel. And so the idea here is that, we're migrating away from IP tables. OVS is one way to attack that problem, and something like eBPF ends up being another way to attack that problem. And there's some advantages to OVS that I think are really worth calling out. The first one is that it's cross-platform. As we see a lot of customers dealing with Windows, dealing with Linux, as we see Windows become more and more real in the Kubernetes ecosystem, having a networking layer that is industrial strength and works across all of these things is actually really, really good. The second thing that I think is really interesting about using OVS here is that OVS is very mature, very well tuned, and has a hardware extension model. And so one of the things that I think you'll see on the web page here, and I haven't watched it yet, so don't quote me on it, is a webinar talking about how can you use Antrea with Mellanox SmartNICs. And so this idea of we now have the right mechanisms to actually install a CNI and have that take advantage of advanced hardware like SmartNICs to be able to do offloads and implement more policy, that type of thing, I think is really exciting and opens up a lot of possibilities into the future. I don't know if ConnectX is InfiniBand or not. Is it pronounced? How is it pronounced? Is it Antrea or Antrea? Antrea. I'm going to say Antrea. And yeah, and so there's a whole bunch of great discussion going on in the chat here that I'm not tracking. So hopefully you're not, I'm not saying stupid things and you're correcting me here. And then along the way, so that's the sort of the unified and sort of the flexible and extensible, which I think is really interesting. And then, when this team gets started, they really did ask themselves, what are some things that we can do to really move above and beyond some of the other solutions in this space? And a lot of this is ease of operations, troubleshooting, visibility, tracing. So there's, as we start going through this, you'll see that there's a real focus on making sure that as an operator, you can actually get a lot more insight to what's happening in your network. And I think, there's a lot of folks here that are, close to the NSXT team here at VMware. And that brings expertise around OVS, but it also means that they really understand what are the needs for operators when they want to debug these things, when they want to understand what's happening under the covers. Okay, so that's sort of the why Antrea pitch. There's a lot to cover here, and so I'm going to do my best, but I'm sure I'm not going to be able to cover all of it. But hopefully this will at least get us started. So I want to start with bringing a cluster up. And the easiest way to do this, I'm going to do this on Amazon and EC2, and hopefully I haven't timed out here. Oh, look at that. I still have access to the console. Okay, cool. Is to use a pre-built AMI. And so a SIG cluster lifecycle actually maintains a whole bunch of pre-built AMIs here. And you can click on this and actually see the different Kubernetes versions across the different base Linux versions, multiplied by all the different regions for AWS. And so you use this decoder ring of I want Kubernetes, the latest version on Ubuntu 20.04, and I'm going to be running in US West 2. And so you copy this magic incantation here, and you can actually go ahead and start launching a machine on that. These are all built via this image builders project, and so this uses a combination of Ansible and Packer to be able to build images for a whole bunch of different environments. And so if you want to use the image builder as a starting point to start building images for your own nodes, or if you want to see everything that goes into those nodes, this is a great resource there. I love how there's a ton of back and forth in the chat about the deep features and the plans for OVS. That's amazing. Okay, so I'm going to go through, I'm going to launch this. I actually created this launch template earlier as I was doing this, just to sort of save the clicky. It's a very simple, we're doing a T3A large. I'm not sure what exactly that means. I haven't been keeping up with this stuff. A 30 gig EBS volume. starting with that image that I named, and then simple network with a, I'm giving it a security group that allows SSH into any of these nodes and full communication on the subnet. And so that's how we're setting things up. And so let's go ahead and we're gonna launch this thing, and we're gonna create 3 of these things. And I'm just gonna hit go. And then when you do that, you can click back to EC2 and see instances. Wait, did it launch? There we go. So these things are up and running. You can see they're initializing. And what I'm going to do is I'm going to give them names. Control plane, just so that we know what's going on. Node 1 and node 2. So there we go. And so those things are coming up. One of them's already up and running. And then I'm going to switch over to VS Code here, and I have a config file. I'll check these into our GitHub repo. We're going to be installing Antrea on the 10.20.0.0/16 network. And so that's the network that the pods are going to actually use. And this is something that you'll see as we initialize using kubeadmin. This becomes one of the inputs there. And then I'm going to copy the external IP addresses of these things so that I'm not, always going back and forth here. Let's see, there's the control plane one. Node 1. Now, if you're going to be doing this a lot, don't do what I'm doing, because this is really fiddly. And you could start writing your own automation of this using something like Terraform, or you could just bite the bullet and start doing cluster API. This is useful if you're just doing a one-off type of thing, and it shows you the nitty-gritty of what's happening kind of a little bit under the covers with cluster API. But this is no way to actually manage things, at scale. Why not Cappy? Because I wanted to show the installation of Antrea, and if we set it up with Cappy, there would be too much magic going on. And so this is the goal going on here. Okay, so we have this stuff, and now I'm going to go into a terminal, and I'm gonna dot that. And so this essentially says run that in my shell, but don't run it as a sort of a shell script, but actually source it in. So you could also do this with source config.h, same thing. .shell. So now what I can do is I can do echo cp, and I see that here, and I can do ssh ubuntu at cp, and now I'm actually into my control plane node. And the nice thing here is this has containerd all set up, configured, has the kubelet installed. It's ready to go so that I can just run kubeadmin on it. And then we're gonna and then I have some notes here. Actually, let's go back to our notes here. This is the stuff that I'm going to we'll go through this line by line here. So the first thing is that I'm just having that pod network that I talked about earlier. And then I'm calling kubeadmin init, and we're passing in the pod network sitter into that network range into kubeadmin init. And what this will do, it will activate essentially some code in Kubernetes to help you to be able to assign a slice of that large network range to each pod. To each node as the node comes up. So this is sort of a helper to be able to partition out your pod network to a bunch of nodes. You don't have to run this way with Kubernetes. Some CNI providers actually do all this stuff behind the scenes themselves. But the way that Antrea works is that it's working to be Kubernetes only and lightweight. So it really defers to Kubernetes to be able to do this stuff. So we're going to go ahead and do this. And this is the magic of kubeadmin, is that it's going to do a whole bunch of really interesting work here. Oh, I got to run it as sudo make me a sandwich. Okay, there we go. And so it's going to be using the latest version of Kubernetes. It's going to create all the certificates to get everything bootstrapped. It's going to start up all the control plane things as what we call static pods, and then wait for those things to actually boot up. And so it'll take a few seconds here for this to happen. It says 4 minutes, but it rarely takes that long. And then what it'll actually output when we're done, it'll all put a command line that, hey, if you go to any of those other nodes that we launch and run that command line, those nodes will actually come up and join the cluster. And so what we see is that there's two parts to this command line here. We'll go through and we're going to copy and paste that into here so that we don't lose it. And you all don't have access to these things because they're you don't have SSH access, so it's not super dangerous for me to do this. If I actually expose my control plane to the world, these tokens would actually be probably dangerous for me to share. But what we have here is this is a token that actually is used to authenticate the kubeadmin, or sort of the bootstrap process to the API server. So the API server knows that you're allowed to add a node. And then this hash here is used so that you make sure that you're talking to the API server that you think you're talking to. So that's what's going on here across these things. So we're going to go through, we have that up and running. And then the other thing is that at the end of kubeadmin, and actually it dumps a kubeconfig into etsy-kubernetes-admin.conf. This is essentially your root key to the cluster. So do not lose this. And then it says, okay, you know, you can go through, and if you want to sort of start using your root key, you execute these commands, and it copies them to the right place in your home directory on this machine so that I can now do kube control get nodes, and I see the nodes that I have, maybe. There we go. And we see we just have the one. It says master now. It'll say control plane in the future, which is exciting. Now, one of the things that you'll see here is that it's like, hey, you know, this node is not ready. And kube control says, hey, you have to actually install a networking provider. And so this is where Antrea comes in. I'm going to actually go through and I'm going to actually go through and have the other nodes join before we go ahead and install Antrea. But you know, with well-designed CNI providers, it doesn't matter what order you do this stuff in. You can have the nodes join and then install CNI, or you can install CNI and then have the nodes join. And so that idea of like being order independent and having things just settle is a really good quality in distributed systems, because it's very difficult oftentimes to control the ordering of things. So it's great to actually see that that's the case here. All right, so we're going to go through. I'm going to go through and log into node 1. And then copy and paste this command line that I got. Now, it turns out that that token expires after about 24 hours. And so if you want to add nodes after the fact, you can allocate new tokens like that. There's some kubeadmin commands to be able to do that. And you can set your own expiration on those things, anything, you know. And so, you know, depending on how you're using kubeadmin to be able to do that stuff. All right, so we got that, and now we're going to do node 2. Boom. Oh, I keep doing this. And again, this is all the automation that Cluster API will do for you. Okay, so there we go. And then now I have a helper script here called create-tunnel.sh. And what this does is it goes through and it copies that kube config down. It sets a environment variable, and then it sort of mangles the kube config a little bit so that we can connect to it, because and then it starts an SSH tunnel, because we have the API server running in EC2. I'm here on my Mac at home. I don't want to expose my Kubernetes cluster to the world, and so I'm going to actually use SSH to forward network connections there. But now when I run kube control is not going to talk to the API server on the IP address that the API server thinks it has. Kube control is going to talk to the API server on localhost. And so this is essentially saying, hey, kube control, when you want to talk to Kubernetes, start on localhost first. Like, you know, hit localhost. But you'll then get an error saying like, hey, the server certificate that I got doesn't list localhost there. What the heck's going on? And instead, it actually lists a couple of the IP addresses that you're going to go ahead and see if you were inside the cluster. And so then the next thing we're going to do here is like, hey, you know what? If one of the certificate addresses is that IP address here, that's okay. We'll still verify it that way. And so this is all sort of mangling of the kube config necessary to be able to have it work through an SSH tunnel. And then this is the thing that starts up that SSH tunnel in the background. So I'm going to do, so first of all, am I already running one? I am not, which is a good sign. And so now I'm going to do a source of this also. And the reason why I'm doing a source is because it's going to continue to run in the background, and I want it to actually do this, set this environment variable for me. So now I should be able to do kube control get nodes, and boom, there we go. And you'll see they're still all not ready because we haven't installed Antrea yet. Now the next thing that we're going to do here is I'm just going to start up, Octant here. And so Octant is really cool, and it's a good way to actually start exploring what's happening here. So I can go to kube system, and we can see, what's running, what's not running. You can see core DNS is not happy. It's pending, probably because it needs to have the networking up and running before it's ready to go. All right, so now let's go ahead and we're going to install Antrea. And so it can be easy or it can be hard. I'll do it the easy way first, and then we'll actually dig into some of the more harder ways to do this. Oh, let me actually go through. Here's the directions to install it. And we're going to be essentially doing this method here, where we're pulling this thing directly down from GitHub. Usually, I'm like, hey, don't do this, but we're going to do it this time just to get up and running. And so, but we're gonna dig into it a little bit more later. And so this is installing a whole bunch of stuff. What you'll see here is that we have a bunch of custom resource definitions, some service accounts, a bunch of roles to allow these things to talk to each other, and then there is a config map, which is we're going to get into that. That is essentially the Antrea config. And then there's the controller, which essentially is the policy controller, but it's actually not used when you actually launch pods. Pods can launch even if the controller is done. And then there's a daemon set that runs on each agent. So there we go. Duffy's asking, is this using the in-kernel OVS or installing one? I believe it's using the in-kernel OVS. Can you all confirm that? Yeah, so the built-in kernel module. And so what's common in these cases is that these daemon sets, if we were going to, go look at this thing in Octant, is that, let's see, daemon sets in kube system. Here we have the Antrea agent. What you'll see here is that it's running a bunch of pods. We have a bunch of pods here, and each one of these pods is running a set of containers. There's one for the Antrea agent, and there's one essentially running the OVS things. Start OVS is the command being run there. And it's mapping in a whole bunch of the sort of host path stuff. And so these types of things are pretty intrusive in terms of what they do with the underlying machine. And I'm assuming that as part of it, this start OVS actually sort of activates and starts using that kernel module. We built our own versions of the OVS daemons, though, as we sometimes need to apply patches. These are included in the Antrea Docker image. So it's using the kernel module, but there is essentially an Antrea version of the user mode components that actually fit with this. And what you'll see, you'll see things like, okay, we have depmod and xtables lock, and there's a whole bunch of paths here that are getting imported into this pod. And then there's probably, I assume, /proc and lib modules and stuff like that. So all sorts of stuff to be able to make OVS work. But the fascinating thing here is that, there's I'm not an OVS expert, and I now have OVS up and running, which is actually pretty cool. So with that, now I can do a kube control get nodes, And you can see that they all mark that they're ready yet. So we now have effective networking up and running. Oh, one thing I should note is that this cluster that I built right now, this is a bit of a toy cluster. The one thing that we didn't do is actually set up the AWS cloud provider. And so we're not going to get access to ELB. We're not going to get access to EBS volumes, that type of thing. I don't think we need it for being able to explore Antrea, but just something to be aware of here. All right, so we are up and running. We got Antrea installed. Now, the next thing I want to do is I want to actually install a test application. And then so we are going to, there's the command line, ant control. You guys missed the opportunity to call it RAID or something, you know? And so this is fascinating. You can actually run it on a pod by essentially execing into the pod. And so that's one way to get access to it. Or you can similarly go ahead and download it onto your workstation here. And so we can go through and we'll go to the releases page. The uninstaller is RAID. Yeah, get rid of the ant. And so we're looking for ant control Darwin, which is Mac x86. So I'm gonna copy link address, curl-lo of this thing. That'll download that. It's pretty chonky. Oh no, this one's not super. 40 megabytes. I just have a fast connection. You want to do a chmod plus x of ant control. So this essentially says make it executable, and I'm just going to rename it like that. So now I can do ant control and, get, and I don't know. So this is like, we're starting to hit the limits of the stuff that I prepped, and so we're gonna start exploring now. The next thing that I want to install is that there's an Octant plugin here, which I think is really exciting also. And so it took me a little bit of working to figure out how to install this. But we're gonna go through, and hopefully me calling it ant control is not bad. Hopefully the team doesn't get mad about it. Yeah, so the Octant plugin is really cool. So the way that you install the Octant plugin is that you create a directory in .config, and then I have like gcloud and htop here. If we do a make dir octant, this is the default directory. You can override it with an environment variable. Make dir plugins. Originally I did this, I left the S off and it didn't work, and I was very confused. And then you can install Octant with brew, all that stuff. And then now I'm going to do a curl-lo of this, drop this in here. Similarly, this is a Go binary. And then I need to chmod this also. And then we should be good to go. 135 is what we're on. Okay, so there we go. So now we need to restart Octant. So I'm gonna kill Octant, close this tab here. And if all goes as planned, we have a new tab down here. Ooh. Oh man, we're gonna have to like feedback for the Octant folks that if you have too many things here on the left, there's no scrolling on this thing. It actually it overflows. I have a relatively small window. Let me take a note of that. I definitely want to give the Octant folks a shout out on that. Octant overflow. But here you can see that, Antrea now starts providing. Oh, okay. So if you expand this thing out, then you can start scrolling on this. Okay, cool. You get an overview here of what's going on, and then there's controller info, and then as we start actually getting deeper into it, you can actually start visualizing trace flows, which I'm going to be really interested in understanding how those work and exploring those. So, okay, so we got the tool set installed. So that's pretty cool. And now we actually need an app to actually play with against this thing. And so I'm trying to think of something that is not too overly complex, because there's the hipster shop that the GCP folks did. I'm guessing that one probably uses like EBS volumes or persistent volumes or what have you. So with this one, I'm going to be using the Buoyant folks, the folks who do Linkerd, created this demo app called Emoji Voto. And this thing's really fun. And so I'm going to go ahead and apply that. And it's essentially, it's an emoji voting app. And they built it so that they could actually do live demos as part of conferences and have people start voting on which emojis they like the best and that type of thing. And so this is a really simple, and so huge thanks to the Buoyant folks for this. This is a really simple sort of microservice-y app where we have a web server, we have the voting thing, and then we have the sort of emoji server. I don't know, they just sort of split things up. And then they actually also have a vote bot that's a traffic generator that will just vote for something at random every second. So like each, and it's hard coded. I looked to see if I could like ramp it up, but each vote bot actually does one request per second, and they start with one of them. So now if we go through and if we look at the Emoji Voto namespace and look at the namespace overview, we can see that it's up and running. Now this is a really cool feature of Octant, by the way, is that we can go down into the web services here, and I can just hit start port forward, boom. And then I get a link, I click on that link, and it automatically manages essentially the kube control port forwards for me. Super easy, super great to be able to click on that link and actually see the thing come through. And so now I can go through and actually sort of like vote on which one I want. You know, obviously, you know, you gotta be that guy who finds the poop emoji and votes that one up, right? Like, you know, because we're all 10-year-olds at heart. And then as part of their demoing, and I don't think this actually does show some of the difference between service meshes like Linkerd and Istio versus Antrea, is that I can go through and actually click on the donut and it'll give me a 404. And so the Buoyant folks built in sort of an error path here to show that, and because this is an error at the sort of the application HTTP level, that's the type of thing that typically shows up and becomes part of the service mesh observability. This is not something that something like Antrea would care about. This is the type of area that Antrea is like, hey, I move packets, don't get me involved with your HTTP errors. And so that's another example of the differences between these. So there we go. So that is that's our demo application here. I think we're all set. We got it installed. We can actually see what's happening. Now, some of the features that I would love to, you know, and I would love for you all to help vote and decide where we want to actually go from here. We can go through and start installing Prometheus and look at Prometheus metrics between the different things. I think that's something that's interesting. There's also a Kibana dashboard for doing network flow visibility. That's not something that I've explored yet. We can start exploring network policies and how Antrea deals with those, which I think would definitely be interesting. Or we can start looking at trace flows, which are ways that Antrea can start grabbing the trace information and dumping that out. Yeah, so Tiffany, if you have a markdown link that you want to share with folks, feel free to actually drop that in like the reference links down here on the HackMD. And so that is HTTP TGIK.io notes. So that'll get you there. So what do folks? So we see some observability of the different layers for debugging, some for trace flows. We got a lot of trace flows here. All right, let's go ahead and play with trace flows. And then from that, I think maybe we'll start digging into some of the networking topologies, networking policies, because I think that would be good. Cool. All right, so I haven't done this yet, so I'm going to totally be relying on the Antrea team folks to actually help me out here, because I was looking at, and I do have some questions here, and hopefully we can make it work. Now, the first thing that we need to do is that a lot of these features are relatively new, and they're actually under a feature gate. And so there's feature gates here, and these things are part of the Antrea agent configuration that you can go ahead and actually start turning on and off. These things are all in alpha, and there's this idea that we're going to be able to graduate these things over time. So my first question for the Antrea folks is that if I go through and start changing these options in this configuration file, will the agents and the controller pick these things up without me having to restart them? Or do I have to force a restart of these controllers to be able to change this stuff? And so that's the first question. I'm going to go ahead and, okay, so we're going to need to restart the controllers and the agents. Okay, so that's, okay. So there's two things that we could do here. We could totally YOLO it, where I can use something like Octant to actually go through and edit this stuff live. So that's option one. Or option two would be that we actually start using the customized templates that are actually built into the Antrea repo. Do you want to see me hack it, or should we do it the right way? What do you got? What do y'all think? Should we YOLO it, or should we do it the right way? Lamatti's saying YOLO. All right, let's YOLO it, and then we can go from there. All right, so we're going to go to the Cube System namespace and config and storage, and we see config maps here. And we see that there's here's the config. Boom, right? And this is just a read-only thing that we actually see here. But if I go to YAML here, you can see that I can actually go through and start editing this. And so this is like one of those YAML inside of YAMLs. But we're going to turn on the Antrea proxy. So the Antrea proxy actually ends up using Antrea to implement things like service IPs instead of relying on Kube proxy to be able to do that through IP tables. We're going to turn on Traceflow, which does packet tracing. We're going to turn on Antrea policy. Now this is really interesting. Antrea supports, standard Kubernetes network policy, but then also has another Antrea specific policy engine that provides sort of tiering and policy at the cluster level versus only doing those things at the namespace level. So that's really cool. Flow exporter exports pulled contract connections as IP fixed flow records from each agent to a configured collector. So that looks super cool. And then network policy stats. So we'll go ahead and do that. And let's see if there's any other things that I should be turning on as we go. Yeah, we're sticking with Geneve as our tunnel type. We don't have to muck with the MTU. We're not doing IPsec. The service cider is the same. We don't need to change that. Trafficking cap mode. So this is something that's interesting, and the documentation goes into it. Antrea supports encapsulation, no encapsulation, a hybrid mode where if you're on the same subnet, it doesn't encap, but across subnets it does. Or it supports essentially a network policy only, where essentially it does the enforcement of the network policy, but then essentially does this technique of CNI chaining so that it uses an underlying other CNI mechanism there. Oh, Zhenjun says, never tested Traceflow together with Antrea network policy, a little worried. I mean, come on, Zhenjun, we're going to turn on all the options at once. We can always turn it back off. Okay, so you're saying the formatting may be wrong. Let me go back and recheck my formatting here. Oh, feature gates. Okay, so they do have to be indented. Gotcha. Ooh, and this, gotcha, because this is a YAML file. Okay, cool. Thanks for the heads up on that. Flow poll interview, flow export frequency. I'm just going to leave those things. Oh, enable Prometheus metrics. We're going to turn that on also. Yeah, the name of the features must go under feature gates. So I think I got it fixed now, hopefully. Oh, and then, yeah, there's feature gates. Okay, so cool. So hopefully we're good to go there. And then there's another one. So that's the configuration for the Antrea agent. And here's the configuration for the Antrea controller. And these things, we're going to do true. Now, when I change this, it will not go into effect right away. And enable Prometheus metrics, we're going to say true there. Enable, okay, let me make sure. Was there one that I missed? This one, does this one need to be, I don't think this needs to be indented, does it? This one, I don't think, this is not a, this is a different thing. This is an option, not a feature flag, I think. Right, because this is correct. Okay. So Lamati's saying, do you still need kubeproxy if you run Antrea? I don't believe tabs are force spaces and stuff. Let's figure out. Let's see how it works. If we totally screwed it up, we'll go through and actually go back and fix it. Okay, let's do 2 spaces instead of a tab. Let's do that. I don't trust. This is, I'm saving this for my talk on, you know, why YAML is hard. This is a great example here. Okay, so I think that works. Like I said, we're YOLOing it, so I'm just going to hit update here. Boom. All right, so this updated the config map, which is great. But it hasn't gone into effect yet. And the way that config maps work is that it will actually update that config on disk for these workloads. But a lot of programs only read their config at startup time and don't notice if the file changes out from under them. And so you really need to go through and actually cause a restart for them to actually be able to pick up the new configuration changes. Oftentimes folks will deal with this, and this is the way that Customize does, by giving the config map a unique name, and that name ends up being maybe based on the hash of the contents. And so that way, if you were to actually change this, it would create a new config map, make the workloads depend on the new config map, and then have those things go ahead and updating the config map would actually cause a change in the template and cause essentially a version upgrade. Yeah, so for those who don't know, I'm doing a talk at Software Circus, a virtual conference called "I'm Sorry About the YAML." I just submitted my my abstract for them, where I'm going to talk about why we did YAML and why people hate it and what the options are. All right, so now we're going to go through and we're going to look at workloads here. I'm going to look at pods, and this is another thing that we can do is I'm just going to go through and, you know, delete this one. And so as I delete these pods, what should happen under the covers is that for these particular ones, the daemon set should actually go ahead and restart them. And then the controller, similar type of thing, where I'm going to delete the controller. And yes, and so what we see is that we have new ones that are actually up and running. They're seconds old instead of minutes old. And these other ones are in the process of either dying or getting restarted. And so I just went through and actually, this is part of the YOLO, is to be able to actually make this stuff happen. And so let's see if things are still working. So we'll go to Octant, we'll go down to our port forwards here, and we'll hit this up, and we can still get to the emoji vote and view the leaderboard. So things are still happening great. All right, so as long as we're in Octant here, I'm also going to go to Emoji Voto, and I'm going to scale up the number of bots that are voting. And so that's under a deployment, vote bot. This is also YOLOing things. I don't recommend this for production, but it's fun to be able to play with stuff like this. You know, clearly managed fields, there's a lot going on here, but we can make that go away. I'm going to change replicas here to like 10 and then hit update. And now if we look at pods, you can see this is actually a good advertisement for Octant, because you can see as these things actually come up, Octane actually gets live updated on what's happening here. Should be, assuming that they actually come up. Uh-oh. Don't make a liar out of me, Octant. Should be coming up. It's pending, pending, pending. I'm now worried. VoteBot is not coming up. Good ad for Octane. Yeah. Well, Octane's maybe not doing the problem. Maybe not. Let's see if I reload. Does that do it? No, it's actually a problem. So this is pending. Why is this pending? Let's see if we can figure it out. Container's not ready. Uh-oh. Uh-oh. All right, Antrea folks, help me out here. What did I do wrong? Failed to create pod sonbacks, RPC error, unknown destination, failed to set up network. So I restarted the Antrea agents, and now they're not happy. What did I do wrong? Looks like I'm missing a sock. All right, so now we're gonna do a little bit of debugging. It could be a format in the debug mat. Yeah, so let's actually go through and we're gonna look at the daemon sets in Cube System. We're gonna look at Antrea agent. Oh yeah, see, one of these things is not running. It's the Antrea container is not running. Let's look at volumes, taints, tolerations. We should be able to get to, oh, we'll pick one of these pods, look at the logs for the OVS container. Display timestamp, OVS server. All right, here's the problem. Failed to validate flow exporter, IP fix flow controller address should be provided. Okay, so that looks like it's a different issue. This is in the Antrea agent container logs. What do I do to fix this? Is this something that I have to do in the config map? So, and let's see. So, okay, so the problem here is that we're using flow exporter, and there's a feature that runs. So flow exporter sends IP fix records to a flow collector. We don't have a flow collector, and so the agent's actually not starting up. Okay, so we should go through and let's go ahead and we'll disable that particular feature. Hopefully we can do that no problem. I hit a little bit of a snag earlier on this, but we'll see what's going on here. YAML flow exporter, right? We're gonna go through and do that. And is that a, that is not a, okay, so it's just there. So I should be able to hit update, sweet. And now we're gonna go back to the daemon sets, Antrea agent, and go through and delete, delete, delete. It should default hopefully back. Oh, yep, and now both of them are running, so we're good to go. Let's go back to Emoji Voto. And now the VoteBot is now coming up live. All right, so this is actually fascinating. And I'm glad that I love hitting snags like this because there's a couple of really interesting things to see here. I was mucking with an alpha feature. So it's great that these things are marked as alpha so that folks know, hey, like if you're going to be using this feature, you're going to be bleeding edge. And so I'm glad that when I hit a snag with an alpha feature. So that's the first thing. The second thing is, I don't know if you noticed, is that Antrea wasn't able to allocate new IP addresses, but pods that were already deployed worked just fine. And so what this shows is that OVS, the stuff that's happening in the kernel, it keeps doing its thing even if the user mode components are actually not running. And I think that's actually really, really interesting. Those flows are set up, things are moving, it continues to cruise along, even if the Antrea agent is in a sort of somewhat messed up state. It meant that I couldn't deploy new pods, but it meant that the current pods that were already there were running just fine. And so I think that's actually really, really interesting. Yeah, for existing connections there, it'll actually keep forwarding stuff. So if we go back now to the port forwards and we look at the emoji Vodo, we can see that we're starting to see some higher counts here because we have more traffic happening. All right, so there we go. Now the next question is, we actually get help from the OVS community to make that possible. That's cool. So Lamati's asking, what functionality does the Antrea agent provide? It actually does the configuration of OVS, but once OVS is up and running, it's up and running and doing its thing. Yeah. Okay. So now the next question is, how do I actually set up an Antrea Traceflow? And I haven't done this before, but we're going to go ahead and we're going to say start new trace. And the thing that I'm interested in, and I would love to understand, is that I want to know the source namespace. So let's go through and we'll actually launch another Octane instance here so that we can actually sort of copy and paste things between them. And we're going to go through and we're going to look at emoji Vodo, and we're going to look at all of my pods. And let's say we're going from this VoteBot. Okay, so this is the thing. This is our source pod in the emoji Vodo namespace. Now the next question here is, what do I put for a source port here? Because oftentimes it'll be an ephemeral port that you're actually originating from. Do I have to actually pin down the source port that I'm using? Or is there a way to say any connection from this particular pod works? Can I actually, like, ideally I would be able to put like a star here. And so that's my next question for the folks here. It can be a random one. And so will then that actually become a filter? Will I not? I can keep it empty? Okay, I can keep it empty. Okay, cool. So I'll leave that empty. And then the destination, this thing I believe calls into the web pod. And I think this is a place where the tooling could get a little bit easier here. And I think this would be destination namespace is also emoji Vodo. And this could be, the destination type could be a pod, a service, or, oh, let's do the service maybe. Or let's start with the pod. We'll start with the pod. And then the destination port here ends up being 8080, I believe. There we go. Okay, so I'm reading, I think Octane feedback for us should mark required fields with a star. Okay. This function generates traffic, so source port is non-consequential unless a policy is filtering on that. The trace packet will, oh, I see. The trace packet gets generated by Antrea, injected into OVS, and so a random, okay, so this is like, I want to simulate a packet, sort of like when you're doing plumbing and you like put a little piece of dye in a pipe and see where it shows up on the other side. I got it. Okay, so this is not the same as saying like, hey, I want to do a packet capture. So I'll go ahead and submit that. Oh, look at that. That's super cool. Okay, so here what we're seeing is that we're actually going, emoji Vodo, it's going through spoof guard. It gets forwarding, output, delivered. This is all within the same node, okay? Because in this particular case, we're doing a little bit of a hairpin where the voter and the web are actually on the same node. Okay, so that's cool. And then, okay, so I can do Traceflow info. Let's now do another trace. Emoji Vodo. Source pod is, let's pick one that's running on a different node. So this one's running on a different node, okay. Okay, the packet capture is in the roadmap. Okay, cool. Doesn't matter. Destination is going to be the same pod that I had before. Yeah, being able to essentially modify and sort of submit new traces without having to refill out that form would be useful also. We'll go through the destination, emoji, Voto, and the destination port was 8080. So we'll go ahead and we'll submit there. It's running. And then Jinjun saying if you have network policy applies to traffic, it will show the in the Traceflow results also. Uh-oh. Did something bad happen? It's running. Does it take a while? So this is actually continuing to run. Uh-oh, sounds like maybe I hit a bug here. Did I maybe fill out the form the wrong way? Let's try it again. OG Voto. Source pod is, so the destination pod, well, let's get that right. The might be due to Antrea policy enabled. Okay, so there might be a weird interaction here that we're seeing. Let's try one more time. Maybe I filled something out wrong. OG Voto. Source pod is this vote bot. And the source port, let's be 1000. Okay. Okay, maybe that one looks to be running also. Oh man, I'm sorry guys. I screwed up by putting together a bunch of options I shouldn't have. All right, so what we can do is let's go through and turn off the network policy stuff real quick. We'll go back and edit that. Edit that in Cube System and then restart things again. Bug. Well, you know, if you don't find bugs, you're not having fun, right? So we'll turn off Antrea policy here. And we'll turn that back on as we start, like if we start digging into that, and we just won't run both of these things at the same time. And then I'll do an update here. And then daemon sets. The Kubernetes policy should work, so we can still play with that interaction there. Oops, not the kube proxy. There we go. Now let's go through and kill these. It might be cool to build a system where this type of configuration could actually be live reconfigured using like an API and something like Ant Control. So Jay's saying that he's learning a lot from watching me do this. You know what? I hear this all the time. There's nothing like a, you know, knowledgeable enough to be dangerous noob to make people feel nervous about their project. And so I try and be nice as I do this stuff. So Wimo's asking, can you have more than one CNI in your network? I think there are some projects that actually let you essentially have a meta CNI that can actually make decisions to redirect things to multiple CNIs. There's also this really interesting project called Network Service Mesh, which is a different type of service mesh, which you can think about it as like virtual Ethernet wires, which starts to actually create, you know, solve some of the problems that may drive you to want to have multiple CNIs. Okay, so there we go. So we have that up and running. Hopefully those things are up and running now. Let's go back to the Traceflow. And these things are... Okay, so we got a couple that failed. So we're going to go through and we're going to start a new trace. Emoji Voto. The source pod is this guy here. Yeah, okay, that's the name of it, is Multis, support for multiple interfaces per pod with potentially different CNI. So yeah, I knew that that was a thing. We'll do port 10,000. We want to make sure. Okay, destination gvoto. And then the destination pod is the web one here. So this guy here. Port 8080. Maybe. Uh-oh. Running. Oh no. No. All right, let's see what the heck's going on here. Summary. We'll look at logs. All right, so the logs aren't showing us anything too fascinating here in the controller. I'm sorry, guys. Well, I think we can try and sort of like maybe burn it down and start all over again, or maybe the agent log. Okay, so let's look at one of the agents then. Daemon sets, Antrea agent. Which one was it? So this one was running on 103. So let's look at 103 logs. So it's processing the delete event, processing add, update. I don't see it show up there. Likely the destination node does not receive the trace packet for some reason. Let's look at this guy here and see what the logs say. Don't see anything that looks obviously wrong. Clearly I'm not an expert here. Ooh, this is interesting. Received packet. So this was, yeah, okay. Process Traceflow update event. So, do I need to restart the controller maybe? I don't know. So we saw it work for the single node case, so I think we know what it should look like. Metadata, YAML. Is there any sort of, okay, failed with Traceflow timeout. Observation, so here what we see. So node 204 saw it. It sent it to node 103. And then we never got the report from node 103. So that seems to be the problem there. So let's one more chance. So let's look at not that deployments, daemon sets. We'll look at node 103's agent. Here, look at the logs. It seemed like it never actually got. Oh, this thing maybe didn't get restarted. Let's see if we can restart this one. Let's go ahead and restart that. I do love that you can actually debug. You see the traces there. And so if something like this happens, the debuggability there, it actually let me realize like, hey, this one node, the source node actually reported what happened, but the destination node actually didn't. And so that ended up being like, there were enough breadcrumbs there to actually start pointing me in the right direction here, which I think is really interesting. Here we see definitely a lot more going on here. Okay, I'm gonna try this one more time. We're gonna give this a try. And then we'll see. Start a new trace, source Moji Vodo. Okay, the source pod, that's the destination pod. 8080. Emoji Vodo. And then the source pod is, we were going to try this guy here on 204. And let's hit submit. It says running. I think we may have hit it again. Shoot. Okay. Well, we're going to have to debug that offline. It is an alpha feature, so we'll cut them some slack. What I do enjoy is that, you know, so far it really feels like Antrea has been super solid in terms of doing its job of actually getting network packets around, which is great. So Tiffany, we covered the source port not needed. What happens when you do this trace is it generates a packet from the source to the destination and then sort of watches it along the way. And so as it does that, you know, the source port could be anything. So it's not doing a network capture. It's actually essentially, you know, injecting a packet and seeing what happens there. So that's, I think, pretty cool. Daemon sets. And it's the 103 guy that's actually not reporting things. Yeah, it somehow it missed it, so we're not seeing it here. That's really too bad. Okay, well, let's, oh wait, this is interesting. Huh. Oh, these things are not, oh, it's from all containers. Oh, this is, okay, this is feedback for Octant, is interleaving log lines. What we see here is that these are logs from Antrea OVS and these are logs from Antrea Agent, and the timing doesn't actually line up. I would expect them to be sort of interleaved, and so that would be a feature request for the Octant folks there. And so we see this one is actually just go ahead, fine. This one, oh, processing Traceflow, delete event, update event, but it actually doesn't actually see the packet come through. So something that's worth digging into. Cool. Yeah, there's going to be replay afterwards. You can go to tgik.io and there's a whole playlist of all the TGI episodes going back, 135 of them. All right, let's go through and let's see if we can squeeze in playing with one more thing. There's just so many features here in Antrea. I really am excited about so much of it. So there's the Traceflow guide. We did that. Should we try and do, I want to try and do the Prometheus stuff. Can we go ahead and maybe play with that? Is that worth dealing with, you think? That might be fun. All right, so here I have Antrea cloned the GitHub repo. And so apparently Prometheus, if we go to builds, YAML, let's do I need the RBAC one? So this is actually doing cluster roles, a whole bunch of stuff here. And then it is starting up a Prometheus deployment and a service and a really simple Prometheus configuration here, which is scraping Kubernetes metrics, Antrea controller metrics, and then agent metrics. And then no dashboard or anything. Okay, so let's actually start exploring sort of what's going on here. So I'll just go through and do kube control apply -f Antrea Prometheus.yaml. Boom, that's up and running. So now if we go back to Octant, we should go through and we have monitoring here. Okay, the RBAC one is a subset. Okay, cool. And we can go through and look at services. There's the Prometheus service. We can start a port forward there and hit that one up. And now we're at the Prometheus metric here. Dude, I love that port forward button in Octant. That is like, mwah, so sweet. Did you see how easy that was for me to actually launch something and then connect to it in the browser? I just got to say that is like totally cool. Yeah, I did when we edited the config map before. I think I did actually go through and have it do the agent metrics. Now try the experimental React UI. No, we've done enough experiments. All right, so okay, so here's all the metrics that we have access to, and so what we can look at is Antrea agent local pod count. And so we can say, okay, here's each agent and the number of pods that it's actually seen on that, which is pretty cool. We can go through and do, what's a good one for me to be able to do it? Did you enable metrics on the agent? I think I did. Let's actually see. So total connection count that we're seeing, execute that. Oh, it says no. So maybe I didn't. I thought I did. Okay, let's go back and actually look at the look at the config map again. All right, so we have enable Prometheus metrics here. Enable Prometheus metrics here. So I think I did. Okay, otherwise I wouldn't see the pod counts. Okay. Cool. Hey, Steve, how's it going? All right, so we can go through here. So these are the total connection counts. So what you're saying is that I should scale up and down the number of DNS pods and actually see what that does. All right, let's go through and play with that. So deployments, core DNS. Go through and skip past this replicas. We need a lot of DNS. It's always DNS. Let's kill our cluster with 20 DNS clusters. So that's updated. And so now if we actually go through and execute this, what do we want to look at here? So maybe the agent connection. OVS flow count, maybe? Oh. I'm screwing this up here. There we go. Cool, okay. Scale date, and then look at the Antrea agent OVS flow count table. Okay, so that's what I'm looking at. So we can look at flow count here. All right, cool. All right, so now we're starting. So the way that, I am not a networking expert, so let me actually explain this, what I understand. You can correct me if I'm wrong. The hard part about networking is that it's a numbers game. You're always mapping this number to that number, and the way to do that fast is to have tables where you have a very simple program that says, packet comes in, let me look at this number, let me attach this metadata, and then pass it to this other thing that looks at this number, then looks at this. And this is the sort of the hardware model, because hardware is really good at looking at a small piece of memory, making a simple decision, and then being able to actually do more with it. And so that ends up being a, and so, okay, now we can go ahead and graph here. Okay. And so this is like looking at the different table IDs, the different agents that we see. Okay, and so now I can go through, oh man, I'm forgetting my Prometheus language. I haven't done this in forever, but there's a way that we can actually do a, essentially sum by the instance name. We can do sum by instance. I'm trying to remember. No, I'm wrong. I can't remember this off the top of my head. But you can start doing a whole bunch of sort of math with Prometheus to start aggregating these things in interesting ways. That's cool. The connection may currently depend on the flow exporter feature, and we disable this because we didn't deploy a collector. Gotcha. Okay. Cool. All right, so this is cool. So we can do some other stuff like, now, oh, you know what I didn't do is I didn't actually go into the core. Wow, there's a whole bunch of cool stuff going on here. And some of these things are coming from the Antrea API server, which is, I will get into that too. But, it's the type of thing where, let's see, Antrea agent, ingress, policy rule. We didn't actually do any policy stuff, aggregator stuff. So lots of good stuff here that you can monitor on. All right, cool. Okay, there we go. I had the parentheses in the wrong place. Instance, and then we're gonna talk. What were we doing? We were doing the OVS flow count. Oh, and aggregation. Am I doing it wrong? All right. I must be doing it wrong. That's okay. This is not a Prometheus. Put by at the end of the query. Like this. Some blah by. No, that's not it. I don't know. We're gonna have to. That's not the point here. Okay. But the one thing I want to do, and this is what I want to end on, is that I want to actually dig into. There's this document. If you dig a little bit deeper into the Antrea docs, which is this architecture document, and hopefully this is still up to date. I saw that it was updated like 9 days ago, so by June. And this is actually really, really cool because this actually goes into the nitty-gritty details of what's happening here and what we've actually been seeing. So what we have is that the kubelet uses the CNI interface to actually talk to the Antrea CNI stuff. And then that goes ahead and actually communicates with the Antrea agent to program it, to tell it what to do. And then that actually then goes through and actually programs OVS to be able to do its thing. And then, the agent can actually work through IP tables with kubeproxy to be able to program IP tables if needed. But I think more and more through time, there's going to be less need for IP tables to be able to do this stuff. And then once the pod gets running, it actually is just talking on a bridge. And that bridge then actually gets enhanced by OVS to become part of the virtual switch. Some by, and then I have to actually do the parentheses on that. Oh man, oh, look at that. Okay, I was able to recover the tab. Boom. Okay, yeah. So then you can actually see the number of flows across all the tables. And so this is some of the sort of the fun things that you can do with aggregation and Prometheus. All right, cool. So this is a great diagram that really shows what's going on here. And then the Antrea controller, and we didn't actually explore this because we were just running out of time because there's just so much in Antrea. It actually goes through and it computes the network policies and really simplifies these things and pushes them down. They get implemented in OVS instead of being implemented in IP tables. And this means that they end up being faster and there actually has a lot better scaling metrics versus doing this stuff with IP tables. Similarly, when Antrea starts taking over the proxy stuff, again, you're not using IP tables to do service accounts, makes it scale better, makes it faster. Now, the fascinating thing that's going on here is that it talks about the different things that happen and how things work and the different networking paths that we're talking about here. Is that this Antrea controller actually is both a controller where it actually manages CRDs, but it's also an aggregated API server. And so that means that it is reusing Kubernetes API mechanisms to manage the communication channel between the Antrea agent and the Antrea controller. So the agent says, hey, I need to know my marching orders. It it could go through and talk to the API server directly to be able to do that, and then store all of those things into etcd using the common controller models. But the Antrea team was really worried that it would overload etcd with a whole bunch of information that really is sort of derived information that really needs to actually stay, doesn't need to be persisted to etcd, doesn't need to overload etcd. And so by having the Antrea agent talk to the Antrea controller, having that Antrea controller be an API server, but not the main API server, means that this path ends up being a separate path from this path. It doesn't create load on the on the main Kubernetes API server, and it doesn't actually create load on etcd. That I think is really, really cool. Reusing the Kubernetes patterns, but using them in a different way to manage the relationship between the Antrea agent and the Antrea controller. So it's really like, there's a relationship between the kubelet and the Kubernetes API server, similar to there's a relationship between the Antrea agent and the Antrea controller. Now, furthermore, you can get access to those same things through the Kubernetes API server using this feature. Then I don't think we ever did a TGIK on this, called aggregated API servers. And the aggregated API servers, hey Rouge, how's it going? So, and can you all hear me? Just want to make sure. So those aggregated API servers are a way where you come into Kubernetes API, it does a bunch of the auth stuff that's necessary, but instead of actually referencing the etcd to go ahead and grab that resource, it actually defers to another server to be able to do that. And so I think that's a really novel way of reusing the API machinery in Kubernetes for Antrea, which is actually really cool. So this is like, if you really want to get into the details of what's happening with Antrea, and I feel like we only scratched the surface here, but it's been great. This really goes into a lot of those details. So with that, I think we're pretty much running down the clock. We've been running for quite a while here, and I'm really impressed that so many of you stayed with me for so long. I've learned a lot. It's great to get hands-on with Antrea, and I still feel like there's a ton more that I really need to learn here. And I really, just a huge thank you for the team, to Jay and Janjun and Tonin, to show up and really help answer the questions. That's been wonderful. And thanks again also for the t-shirt that y'all provided me here. So Jay, what do you want me to do, Jay? You want me to actually SSH into a node and do the route-n to actually show? Okay, yeah, let's go ahead and do that, because that was something that I meant to do also. I can go through and do an SSH Ubuntu at say N1. We're now in one of these nodes, and do sudo route-n. Oh, I actually sudo apt get install apt cache. Oh, not sharing the screen. Sorry. I'm bad at this. You'd think I'd learn apt get update. So we'll go ahead and we'll do that. And then I was calling the route command, but it's not installed in this base image, so I have to do that real quick. So if I do route, it's saying no, and so now I need to do sudo apt install net tools. Let's go ahead and do that. Sudo route-n. Boom. Okay, so there we go. So yeah, what we're seeing here is that, and this is really fascinating, is that we're saying, hey, any traffic on this node that goes to 10.20.0.0, which ends up being one of the pod subnets probably for the control plane, that gets sent out through the Antrea gateway interface, which is, this is where like my networking knowledge starts to get a little bit, it's, doesn't actually help me out here, but it sends it out through this gateway interface to this thing here, out through, is this the bridge then that actually ends up being there? And so, so similarly, you can see like for this particular node, so this guy is the 1.0 subnet, it actually stays local. whereas for here it actually sends it out through this as the next hop, as the gateway. So that shows you that instead of playing lots of tricks with IP tables, it's actually real routes that are actually being managed here. And this is what routing was actually built for. And yes, that's the internal port for the bridge. That's how traffic will get to the overlay network. And so that way I can actually go through from here and I can, ping, if I go to Octant and, let's look at Emoji Vodo. And we have the web here, and we'll take this particular IP address. So this is ping. We'll actually do, we probably don't have curl installed, do we? Oh, no, 8080. Boom, and we got the Emoji Vodo thing. And so when I actually do this, what's happening here is the destination here is in the 1.20.2.0 subnet. And that's saying, well, the next hop is 10.20.2.1, which is essentially the gateway. It tells you essentially which node you want to head through. And then that gets sent through this gateway interface onto the bridge. And then OVS goes ahead and takes it from there. And then I can also run OVS, VS. Oh, okay. So if I do this, will bad things happen? Oh, you want to see who won the emoji voting? Let's go ahead. We'll see who won the emoji voting. Port forwards. Let's see. View the leaderboard. The celebration one is winning, followed by the bunny. And I believe they try and they automatically put the donut in there at 15%, but it never gets recorded because it always 404s out. Okay, so OVS control needs to be run inside the agent pod. Okay, so I can go through, and one of the things that we can do here, let's do this, it'll be the last sort of spelunking that we do here, is that if we look at Cube system, if we take an agent, and we'll go through and let's just take one of these guys at random. I can do a cube control -n cube system exec. Paste without new line. Bash, maybe that'll work. Oh, I have to actually specify which container. Which container? There were instructions on how to do this. I had this. -C container. Josh, have a good weekend, man. Thanks for tuning in. Antrea OVS. Okay. Oh, that didn't work. OVS CTL. Or what is the OVS command called? This is me not knowing OVS. Oh, -TI. Yeah, that's right. We have to do the -TI. Bash. Okay. OVS, and now we get all the OVS tools. VSCTL, VSCTL show. Sweet. Oh, this is fascinating. So there's the Antrea gateway internal, but now we actually see that if you want to talk to this thing, here's the and then here's the tunnel out, saying that it's using Geneve as the encapsulation format here. Okay, and then the other one that we can do is, yeah, so here you can see it's all tables and mappings and stuff like this, and this is where my eyes start to spin whenever I'm doing networking stuff. So each pod has an OVS port that actually represents it into the OVS system, which is really cool. All right, I have to run. I'm going to switch back away from the screen here. Thank you, everybody, for joining me. I've learned a ton. This has been great. Hopefully it's a good, gentle introduction to Antrea, and hopefully it gets your all interest piqued. As you can see, there's a really passionate community and group behind it working on it. And so we'd love to see more folks using it, playing with it, and giving feedback to the team. So, that is, I think the biggest thing that I think, I don't know, I'll let them say, but I think, they're definitely looking for more folks to actually, kick the tires, try out some of these alpha features, let them know what you think. A bunch of really friendly folks. And so, thank you so much. Have a great weekend. I'm not sure who's on deck for next week. We never know. We kind of play it by ear. But tune in again next week for TGIK. And thank you so much. Have a great weekend.